Okay, an introduction to thermodynamics. First, some basic vocabulary. Most of this you're probably familiar with, but let's just go over it just to make sure. Exothermic reaction, energy is released. Endothermic reactions, energy is taken in. Energy is the capacity to do work. Work is the result of a force acting through a distance. Kinetic energy is the energy of motion. Potential energy is energy at rest. It has the ability to, but it's not doing anything yet. Thermal energy is the energy associated with temperature. It is a type of kinetic energy. Chemical energy is associated with positions of electrons and nuclei, and it is a type of potential energy. So thermal energy is kinetic energy, and chemical energy is potential energy. Units of energy. A joule is 1 kilogram, meter squared is divided by second squared. 1 calorie is 4.184. And then just to confuse us, we have another calorie with a capital C instead of a little c, or a kilocalorie. This is the one we actually see on our food labels. And it is equal to 1,000 of the calories with a little c, so it is equal to 4,184 joules. And then a kilowatt hour is equal to 3.6 times 10 to the 6 joules. The first law of thermodynamics. The total energy of the universe is constant. Energy is neither created nor destroyed. It only changes form. It goes from kinetic to potential. It can go from chemical to thermal. Okay, so internal energy, E. The internal energy of a system is the sum of the kinetic and the potential energy of all the particles that compose the system. In internal energy change, delta E, is determined by the difference in the energy in the internal energy between the products and the reactants. So here you see your formulas. Okay, so an exothermic reaction, and this one is an exothermic reaction. And we know that we have energy. So our reactants are right here, the energy that the reactants have right here. We add a little more energy, our activation complex. This is called the activated complex right here. And then as the reaction falls, the products have a lower energy. And so the energy is released. So if you're feeling a test tube where we have an exothermic reaction, it will feel warm as that energy is released. So if we're going from reactants to products, this is our activation energy. However, if we're trying to reverse the process, then our activation energy would be from down here, from the energy of our products up here. So this is a more stable compound. So going from reactants to products is more stable because we don't have to add as much energy to get it to react backwards. Now this is an endothermic reaction. And so we have our reactants, takes more activation energy. The energy of our products is higher than the energy of our reactants. So this is a less stable reaction going from reactants to products because it takes a lot less energy to get it to go back the other way. So as you're adding energy here to get it to go over, some of these are going to keep coming back over this hump because this activation energy is smaller. And then our delta H is the difference between our reactant and our product energy levels. So there's our delta H. Okay, so again, if energy flows into the surroundings, it's exiting, so it's exothermic. If energy is flowing into our system, away from our surroundings, it's flowing into our system, so it's endothermic. And so our energy in our system is equal to the negative amount of energy in our surroundings. Sign conventions for Q, W, and E for heat, work, and energy. So heat, if the system is gaining thermal energy, so it's endothermic, then the system will be positive, or the heat will be positive. If it's losing thermal energy, so exothermic, then the heat will be negative. For work, if the work is being done on the system, then it's positive. If the work is being done by the system, then it's negative. And the last one, energy, if the energy flows into the system, it's endothermic. If the energy flows out of the system, it's negative. And so if the energy flows into the system, it is positive and it's endothermic. If the energy flows out of the system, it's negative and exothermic.